The scientific community is anticipating the launch of the James Webb Space Telescope. The James Webb Space Telescope is primarily intended for infrared astronomy. As the biggest optical telescope in space, its exceptional infrared resolution and sensitivity enables it to observe objects that are too early, distant, or dim for the well-known Hubble Space Telescope. Expectations for the most powerful and expensive telescope ever built are understandably high. On the other hand, can JWST live up to the hype? Thanks to the mind-blowing finding by the Space Observatory on Jupiter, scientists have an early response to that query, and they are really thrilled about the results. What has the world's most powerful telescope discovered on Jupiter? Has it finally discovered aliens on this vast planet? Should this discovery worry you? Make sure you watch the video all the way through as we bring you the terrifying new discovery of the James Webb Space Telescope. The $10 billion James Webb Space Telescope is NASA's largest and most powerful space science telescope, and it will explore the cosmos to learn about the universe's history from the Big Bang to alien planet formation and beyond. It is one of NASA's great observatories, massive space instruments that include the Hubble Space Telescope to peer deep into the cosmos. Webb is frequently referred to as Hubble's replacement, but we prefer to refer to it as a successor. After all, Webb is the scientific successor to Hubble, and its scientific goals were inspired by Hubble's findings. Hubble's science pushed us to look to longer wavelengths in order to exceed what Hubble had already accomplished. More distant objects, in particular, are more strongly red-shifted, and their light is pushed from the UV and optical into the near-infrared. Observing these distant objects, such as the first galaxies formed in the universe, for example, necessitates the use of an infrared telescope. NASA's James Webb Space Telescope is an infrared space observatory that was launched from French Guiana on December 25, 2021. The James Webb Space Telescope travelled nearly 1 million miles in 30 days to its permanent home at Lagrange Point, which is a gravitationally stable location in space. On January 24, 2022, the telescope arrived at L2, the second Sun-Earth Lagrange point. L2 is a location in space near Earth that is opposite the Sun. This orbit will allow the telescope to remain in alignment with Earth as it orbits the Sun. Astronomers expected it to produce stunning images of distant galaxies and star-forming regions, as well as analyze the chemical compositions of exoplanet atmospheres. And NASA's flagship space telescope has not let us down. JWST has already captured images of galaxies so far away from Earth that cosmic expansion has shifted their light well into the infrared range, which the telescope is designed to detect. Furthermore, the observatory's near-infrared spectrograph discovered carbon dioxide in the atmosphere of exoplanet WASP-39b, marking the first definitive detection of this gas in a planet beyond our solar system. JWST has also focused its efforts closer to our home Earth. On July 27, astronomers used the telescope's powerful infrared eyes to target Jupiter. Jupiter is one of the planets that is the furthest away from Earth, and we rarely receive information from it. But thanks to NASA, we have been receiving more frequent updates from this massive planet. The planet is not only massive, it also contains many mysteries that have fascinated science since its discovery. However, JWST has now revealed many mysteries. The images that result show a planet that is both familiar and exotic. "We've never seen Jupiter like this. It's all quite incredible," said Imke de Pater, principal investigator from the University of California, Berkeley. JWST's near-infrared camera captured 2 images of the largest planet in our solar system. Jupiter appears to have numerous cloud bands, storms, and auroral emissions in the striking close-up above, which was captured using 3 different filters. The equatorial zone spans the globe and appears bright white due to high-altitude hazes that reflect a lot of sunlight. The massive Great Red Spot in Jupiter's southern hemisphere appears as a bright oval for the same reason. Smaller storms appear whitish or reddish-white all over the planet. JWST has closely captured the surface of Jupiter. The cyan hues reveal clouds buried deeper in Jupiter's atmosphere, displaying light reflected from the planet's main cloud level at a pressure of about 1 bar. The image also shows the transition from the familiar banded structures seen at equatorial and mid-latitude regions to more complex vortices at higher latitudes. Near Jupiter's north and south poles, massive auroral ovals appear as reddish glows. These emissions are caused by ionized hydrogen atoms that can travel up to 1,000 kilometers above the cloud tops. The greenish areas around the poles are caused by hazes in the planet's atmosphere that are 100 to 200 kilometers high. If you look closely, you can see this haze layer extending all the way down to the equatorial latitudes. The image taken by the James Webb also has a rich background of scattered light. The most visible sources are diffraction spikes from Jupiter's aurorae and the bright moon Io, the planet's innermost of 4 Galilean moons, which lies just beyond the image's left edge. The latter spike cuts through the 2 visible moons. A more intriguing type of background light appears near the bottom of this image. Scientists believe the numerous fuzzy dots are photobombed by distant galaxies. The magnificent cloud tops of Jupiter are just one highlight in this wide-field image, which also includes the planet's dusty ring system and the moons Amalthea and Adrastea. Images are only one aspect of JWST's observing capabilities. The telescope's spectroscopic capabilities are also being applied to Jupiter. Astronomers took near-infrared spectra of the Great Red Spot on July 27 and similar observations in the mid-infrared on August 14 and 15. The aurorae of Jupiter, on the other hand, will be subjected to more spectroscopic scrutiny later this year. JWST scientists are optimistic about what the next generation space telescope will reveal about the Jupiter system. Researchers intend to examine cloud layers, composition, temperature, winds, and auroral activity around the world. The thing that is most interesting for the researchers are galaxies outside our galaxy. The James Webb Space Telescope has photographed a planet orbiting a distant star outside our solar system. The massive gas planet is seen orbiting HIPS 65426, a star 385 light-years away from Earth. A near-infrared camera and a mid-infrared instrument were used to capture the image. Sasha Hinckley, an astronomer at the University of Exeter in the United Kingdom, says, "This is a transformative moment, not only for Webb but also for astronomy in general. The planet was discovered in 2017 by a very large telescope in Chile, whereas the Webb telescope isn't designed for such discoveries. These planets are difficult to observe because they are fainter than the star around which they orbit. HIPS 65426b was discovered due to its great distance from its parent star and size 12 times that of Jupiter." The images were analysed by Aaron Carter, an astronomer at the University of California, who stated, "At first, all I could see was light from the star, but with careful image processing, I was able to remove that light and uncover the planet." An Einstein ring is created when light from a galaxy or star passes by a massive object en route to the Earth. Due to gravitational lensing, the light is diverted, making it seem to come from different places. The James Webb Space Telescope of NASA has captured a perfect image of an Einstein ring. The spectacular halo is caused by light from a distant galaxy passing through warped space-time and surrounding another galaxy aligned between the distant light source and Earth. The ring of light in the new image is from the distant galaxy JO 418, which is about 12 billion light-years away from Earth and is one of the universe's oldest galaxies. JO 418 is oriented directly behind another galaxy. The bright blue light at the center of the ring, whose gravitational pull is so strong that it warps space-time around it. Light from JO 418 travels through this warped space-time to reach the foreground galaxy. From Earth, it appears that light has curved around the galaxy, but the electromagnetic waves we see have always traveled in a straight line. This strange effect is comparable to how glass lenses redirect light. This phenomenon, like magnifying glasses, makes light from distant galaxies appear much closer than it is. The only difference is that the lens is made of gravity-distorted space-time rather than glass. As a result, scientists have dubbed this strange phenomenon gravitational lensing. When he developed his theory of relativity in 1912, Albert Einstein predicted gravitational lensing for the first time. Scientists are relieved Webb passed the vision test with flying colours. This means it will photograph not only Jupiter's moons and rings, but also those of Saturn and Mars. Astronomers are also excited to investigate the vapor plumes erupting from Europa and Saturn's moon Enceladus, both of which could harbour oceans. However, the team also wanted to know how fast an object could move while still being observed by the telescope, which is important for astronomers studying flying space rocks. Engineers attempted to track 6481 Tenzing, an asteroid in the main asteroid belt between Mars and Jupiter, to put Webb to the test. They were not let down. JWST has a speed limit of 30 milliarc per second, which is as fast as Mars can go, and it can track targets faster than NASA promised. One study combed through data from many of Webb's distant galaxy fields to determine the rate at which stars formed in the early universe. It discovered 44 previously unknown galaxies dating back to 300 million years after the Big Bang. The findings, when combined with 11 previously known galaxies, show that there was a significant population of galaxies forming stars in the early universe. The swarm of research teams vying to identify the most distant galaxy in the Webb data is perhaps the most visible rush. A number of candidates have been identified that will need to be confirmed through additional research, but all of them would break Hubble's record for the most distant galaxy, which dates back to around 400 million years after the Big Bang. One candidate appeared in a Webb survey called GLASS, which also included another, slightly less distant galaxy in the same image. The discovery of these two bright galaxies by JWST came as quite a surprise. That pretty much wraps this video up, guys. Thanks for watching. What are your views on these images? Let us know in the comments below. Remember, be sure to subscribe to this channel with bell notification if you enjoy watching our content. We upload some pretty awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.